All right, time for another draftphysics.com, debatephysics.com, also a video presentation. So, in a series of 4 videos, this will be included, this one on photons, and mostly dealing with the conclusions that were drawn by physics based on a pretty simple experiment, for which they did it looks like kind of thing, and it really doesn't look like, actually. And if you really analyze it, it's pretty much nothing like. And so their conclusions are way off regarding a thing they call wave-particle duality, that somehow these simple elemental experiments prove that photons have to be a wave because they're doing something only water waves or only waves in a medium do. So they're almost arguing for a type of ether, frankly. But anyway, we'll start with the slit experiment, and it's the foundation for entanglement and superpositions, and all kinds of the major woo that's in quantum mechanics starts with this experiment and their misinterpretation of it, and their deceptions, frankly, lies about what experiments have actually been done, and what actually happens when you actually do the experiment. So we'll start there and deal with how it's really bad science because it's deceptive and dishonest and way underdeveloped. All right, so there's 2 experiments, the double slit and the single slit. And there's a certain logic you could just argue right off the bat. First, let's just deal with the 2 patterns. So the single slit makes a pattern that looks something like this, but there can be 70 or 80 of these little nodes that drift off. So it has a double maxima in the center, and then the nodes are all consistently sized, except they start to get bigger as you go further out, but you can't see any of that because they don't view the pattern on a curved surface. They view it at a non-equidistant infinite plane, which disguises the actual functions. But anyway, so that's the single slit pattern. That's the one you see in water, except water doesn't do this double maxima thing. So water doesn't have that. All right, the real double slit, that is when you have 2 open slits, okay, more than a wavelength of distance between the 2 surfaces, creates this pattern. And yes, it can have all kinds of different arrangements depending on how wide these distances are between these surfaces. And so you can have, it's always an odd number here in the center, so you can have anywhere from 3 to 5 to 7 to 9, always an odd number. And these are the one short of double. So if this is 3, then this is going to be 5, 6 minus 1. If this is 4, then it's going to be 7 here in the middle. So you can understand that that's the relationship that exists, and it's a solid, reliable relationship. Now, what they do in their argument is they say that a single slit in water doesn't produce any pattern. So if you have a single slit in water, it just creates a single wave, and there's no fringe pattern. Doesn't happen. And in light, you get this obvious fringe pattern. So clearly there's not a connection there, because the real truth is, and it's proven by their own mathematics, is that what you're really doing is using vectors from the surfaces. So this distance, the opening distance, is critical to the math. Because really what you're saying is this is how far the 2 points are of a triangle. And you're always just going to make this geometric argument that you have a base for your triangle, and then you're going to have 2 lines, and you're just looking for when this hypotenuse gets a full wavelength longer than this side. And whenever that happens, that would be a point where you'd be starting to go in phase. And then you go out of phase, and then you go back in phase. You go out of phase and in phase as you go full wavelengths of distance. Half wavelength of distance would indicate the most out of phase, and a full wavelength would be the most in phase. So you're basically saying that there's a connection between the frequency of light, that is, the idea that the idea that it comes at a frequency, and you're basically just saying you could convert the line into a bunch of little nodes, and you could just say, yeah, well, I'm going to have the triangle made this way, where I have a base, and then I can have a side that's 2 nodes, and then I can have a side that's 3 nodes. And you're just saying that the frequency is built into the geometry. So their math is accurate as far as they show it to you. All right, in the sense that they're really using 2 points. So they're not calculating a wave coming out of the opening like in water. They're calculating 2 waves, one here on the surface here and one on the surface here. And obviously, those could also just be called scatter. The photons that go near the surface hit electrons that are on the surface, they get diffracted and bent, and they scatter. And so you're basically just scattering what could be called elements of a photon, and you're sending source material from 2 different sources. So you're sending material from one surface and the other surface, and there's points where those 2 pieces you sent are in phase, so they're going to make a photon, and then there's points where they're out of phase. I could draw out of phase as something like that, where there's a bigger distance, the signal isn't reliable, it's not the same frequency. And so that wouldn't be a visible photon. But if they are in phase, that is, if the distance is right, then they'll be hitting at the right sequence, and they'll create a photon that is visible, and it'll create a visible photon in that location. And at the other locations, it's that half wavelength problem. The distance from this surface to here, from this surface to here, is not full wavelength of difference. So they're not going to be in phase, the pieces, so you're not going to have any photons going to those locations. So that math works perfect. That explanation works perfect to understand that it's really the slits. They don't calculate it as 2 waves coming out like that. Okay, that's not what they think or argue. So again, you have to sort of make the point that where's your waves and how are they coming out of the single slit and making the pattern. And so then you can see that in the double slit, because that really reveals they draw it as if they're calculating waves coming out through the slits. Obviously, they don't use this dot here and this dot here as the point sources. And they only do that, okay, when they make these slits so close together, these surfaces, they do infinitesimally close surfaces. And what that does is basically just destroys 2 of the point sources. So if I have 2 headlights and I put them really close together, they're going to look like one headlight. You can't see that they're 2 headlights. They can't make a triangle. So if the base is so tiny, then I can't make 2 lines that are a wavelength of difference. If this isn't a wavelength of difference, then neither of these lines, no matter how long I make them, can ever be a wavelength of difference. So I can't make any fringe pattern. I can't make an on-off pattern because those lines will never be a wavelength different. But if I leave these openings the regular size, and then I claim that waves went through the center, all right, and I use this point with an open slit, that math won't get this pattern. It won't predict it accurately at all. It'll completely get the wrong answer. And the only math that's going to work is math that recognizes that this really is the 4 source experiment. It's the 4 surface experiment. And what you really have are 2 mathematical slits. You have one with a very big distance and one with a very small distance. And the one with the furthest distance between 2 surfaces, that's creating these little nodes, because there's lots of wavelengths of difference when you have a big base to the triangle. Big base to the triangle means lots of places where there's a wavelength of difference. Small base to the triangle, very few places where there's a transition from in phase to out of phase, in phase to out of phase. So the closer the 2 points are, the fewer places there can be a wavelength of difference. The further away they are, the more places there can be a wavelength of difference. So all of the little dots are being created by the big distance, and all of the small, the envelope pattern as it's called, is being created by the places where the smaller distance sources are making a contribution. So the only place you're really getting light, so to speak, a photon, is in the places where both of them are in phase. So that means that all 4 sources are in phase hitting a point. That is the furthest distance and the closest distance. So when all 4 are, you get an on. And when 2 of them are on and 2 of them are off, two of them are in phase, 2 of them are out of phase, that's where you get these empty spots. And that math works perfectly explains. So it really is about the 2 surface experiment and the 4 surface experiment, and talking about slits is losing all sight of the real experiment. It's just a distraction, and it's just inaccurate. It's not the truth. It's not what's really happening in the experiment. All right, not a perfect redraw, but it'll have to do. So in the real experiment really should be done with something equidistant. And what you can sort of understand is you're just bringing 2 single slit experiments into each other. So you're taking a single slit and a single slit and just bringing them close together. And it doesn't mean that you've just created 2 openings and brought them close together. It means that you really have created these 2. This is what changes the experiment, this big distance created by the 2 surfaces furthest away. That's what's unique. The other distances are the same, but that's the new distance you've added, and that's the one creating the little dot pattern. Okay. So anyway, so the pattern has a reliable outcome in the sense that you can measure, you can understand that the real thing creating it is that triangle, and I could take that triangle all the way to 0 degrees, and you could understand that I have a distance, and then I have another distance to this 0 degree point. And this, is telling you how many wavelengths fit here will exactly correlate to how many nodes you have here. So as soon as you know this number, say 16 wavelengths, you know there's going to be 16 of these nodes. So it's telling you exactly how the experiment will function. And there's really 2 experiments here in the sense that these are both off center, so to speak. So you really have 2 separate experiments in the sense that you're only concerned with photons going in the same direction. That is, ones that go this way and this way are irrelevant, because this is less than a millimeter. This whole distance here is less than a millimeter. This pattern is maybe a foot across as you're projecting it. So what's happening in here, inside of 1 millimeter, you can't even see it. So lines converging have nothing to do with what you see as the pattern. The only lines that matter are when elements of the photon are moving in the same direction. That is, they're both going in the same direction. So there's essentially 2 patterns, one created this way and one created this way for these surfaces. And that's why there's a double maxima in the center, is you've really overlapped 2 separate patterns. So they're overlapping. So the 2 nodes that would have been just regular sized nodes are actually overlapping each other, and that's why there's a double maxima. So that's something their physics doesn't explain, doesn't even acknowledge the existence of the double maxima, because it's not consistent with their wave theory. Waves won't create that double maxima. So they just ignore its existence, and pretend, well, we can mathematically create it by just creating a 0 and a 1, and just pretend that we're starting with 0 in one experiment and then counting 1, 2, 3, or we can just make this a 1 and then go 2, 3, 4. And they use that trick to make the fact that the center is double disappear. So when they're counting a single slit, they use 1, 2, 3, 4, no 0. And when they're counting a double slit, they put the 0 in, obviously creating an extra digit. All right. So you can understand that the number of wavelengths will tell you right here. So if this was 16.5, I know that this node has to be an off. So if I know this distance 16 point, I know this is an off. It can't possibly be an on here if it's an off here. All right, because of the circular symmetry. So we know that this isn't going to be a complete on, and what it's going to mean is that the overlap will be less or the overlap will be more. So all you can change by having in phase and out of phase is change how much the overlap is. So in some cases the overlap will look like a little less than 2 nodes, and in some cases, no, it'll look like a lot less than 2 nodes. In some cases it'll look like exactly 2 nodes. So it'll expand and contract a little bit based on in phase and out of phase, based on the base triangles numbers. Alright, so that's probably enough of just the mechanical details explaining why what they say isn't consistent with the actual experiment. The actual experiment doesn't do what they claim. Even when they talk about throwing stuff through slits and getting a pattern, they can't even get that part right, because we know these slits, again, the whole experiment is 1 millimeter across. So this whole distance is 1 millimeter. It's actually less than that, but I'm just giving the benefit of the doubt. And they'll say something like, well, you throw stuff through here and you throw stuff through here and you get a clump over here and you get a clump over here. No, you don't. There's no diffraction here. These two lines will be straight lines and they'll just be 1 millimeter apart here. So if there was to be a pattern created by 2 openings, by throwing baseballs through 2 openings, if I'm throwing the baseballs through slits that are that far apart, then that's how far apart the baseballs are going to be when they land. And so the truth would be is one pattern would look like this and the other pattern would look like that. And so there'd be so little difference you wouldn't be able to see the difference between the throwing them through one slit and throwing them through the other slit. The 2 patterns would look almost identical, because it would be like seeing a millimeter in something a foot long. It's really hard to see a millimeter difference. So there's just a ton of deceptions in what they describe as the double slit experiment. And again, mathematically, it works perfectly to analyze the pattern as being created just by distances. Okay, and it's this outside distance is the key distance, because that's creating the little dots inside the bigger pattern. And so that's the key to understanding the whole thing, is that now you can understand that there's really 2 patterns. There's the pattern created by the furthest distance and the pattern created by the closest distance between 2 surfaces. So you have this close distance that could be either this or this distance. Either one can be the closest. Doesn't really matter. You're still talking about these 4 surfaces. And where the 4 surfaces are all in phase, that's where you have a light. And that explanation works perfectly. It's the 4 source experiment. And if you were going to call it a wave experiment, you'd have to call it the 4 wave experiment, because only 4 waves can create the complex pattern, the real double slit pattern. Alright, conventional physics diagrams a photon as something like this. Okay, some event that has these nodes to it, and they consider this the wavelength as the distance from one complete transition of a node. And that this is the event that is a photon. Now, they don't tell you how many of these things you need, how many of these little lumpy, squirrely magnetic field going this way, an electrical field going this way. And we're supposed to believe that with some radio waves, this could be 10 miles long. So one little blob like that would be 10 miles. So somehow there's some fields, electric and magnetic fields, that are operating over these gigantic distances and precisely bending some sort of pushing energy into this snake-like monster. And that is their proposition. That's the valid, sensible, reasonable explanation. I would argue, no, it's not. Okay. I mean, again, the fact that they don't tell you how many of those lumps you need to make a photon, they don't have any way of describing how it actually hits the surface and how a single electron could be affected by this gigantic, monstrously big thing. Okay, the bigger the wavelength, the more polarization it has. And obviously, when you start getting into the microwaves, the polarization is actually centimeters of distance. How can something moving centimeters of distance be affecting single electrons? Totally unrealistic, frankly. Nonsensical, mush, garbage. So the simple counter theory is sort of vaguely implied by Einstein's statement of using terms like light quanta, okay, and quantum bits of energy. These are kind of the terms Einstein used in his description of the photoelectric effect, and it's clearly reasonable to suspect that maybe photons are events separated by a distance in time, that it's actually discrete bits of force. It's clumps, okay, and you can't have a half of one of these clumps. You can only have a full clump, and the clumps either hit, you either get the full amount, and if there's one missing, well, that's not going to be a photon, okay. And I would argue the polarization is merely these bits of force are traveling the same constant speed, and the simple truth is polarization just means they're a little bit out of alignment. So you could understand that as an antenna would be producing this kind of radiation, that the way it's producing it is it's electricity traveling up the antenna at the speed of light, and it's actually causing these perturbations, these impulses of releasing an object, and that as it goes up the antenna, obviously they're released at different time, and they're released in different places in space. And so it's basically just clumps of energy traveling the same direction that will arrive with a frequency and arrive with a polarization. And so that explanation does mechanically work very well. I'll take it a step further that really isn't necessary for this conversation, but I'll certainly argue that the way we see photons is having them create an electrical impulse. So without that electrical impulse, we don't really see photons. We have to cause them to move electrons, and that's it. And the way they move electrons or eject electrons from a surface is by giving them momentum. And the fact is it's a simple kind of tipping point argument. The first impulse of the photon creates energy. That energy travels through the electrons, and then the second pulse hits and adds energy to one of the subsequent moving electrons, and then the third impulse adds energy and gives that electron even more momentum. So you could sort of visualize the surface of atoms, and you could argue that there's these key electrons, and what you're basically doing is when you hit the surface, you're going to create a disturbance in the electrons binding all of these atoms. So there's electrons that are all under pressure. So when you hit one electron, you actually move all the electrons. And the idea is kind of like a bullseye thing. You could hit the bullseye. Electron here goes over here, one over here moves over here, one over here moves over here, one over here. Then you hit again at some location and push that particular electron, which again causes the same kind of cascade. But the point is that the photon has to hit in a line, like a strafing of bullets on a surface. It has to hit in an alignment, and that'll be the polarization of that particular photon will be in what alignment it pushes energy behind the electron. So it's just really duplicating electricity in the sense that it's forcing an electron to transfer from atom to atom, at least in terms of its motion. It pushes, and the other electron pushes, and the other electron pushes, and so it's the same thing as causing electricity. And to eject an electron, to ionize the surface, you obviously need to give it enough momentum to break free of its bond to the atom. And the way that's accomplished is basically by hitting it quickly before anything can slow down and even go in reverse. So the last thing you want is the electron to slow down and start going in reverse when you hit behind it. You want to hit it while it's still moving forward so you can add energy to it. Add velocity, momentum. All right, so that's probably enough of getting into that. The easy understanding of how frequency is critical to resonance and understanding in phase and out of phase is just a way of understanding adding energy and defeating the addition of energy. All right. So in the case of the double slit, it doesn't take much understanding of the physics to understand there are no flat surfaces in reality. So there's no like, here's an atom and it creates a nice flat surface. Now, atoms mean that there's electrons on the surface, okay, and the protons are back here. All right, and that is how the atoms are configured. So there's always electrons on surfaces because there's always protons for the electrons to be attracted to. They can see places where they can see the proton, and there's not too much electron pressure to stop them from resting there. And obviously their bond is strongest the closer they are, and the further away they are, the less bound they are. And the simple argument would be is when photons, which are a stream of these particles, okay, these bits of force, go into the double slit experiment, the simple argument is they're hitting these electrons. The electrons are jiggling in and out of the surface. That's their heat, okay, and they're obviously, the way they're positioned, there's one direction they're going to more likely move in because of they're crowded. And so they're more likely to move to the one place there's no other electron, which is out. So they're going to move out and move back in. So they're moving constantly in and out. That's what's creating the fact that the fringes spread, is the fact that there's only motion in those directions, in and out. So when light goes through the slits, it pushes it sideways. It doesn't push it in other directions because the electrons are really moving in and out. And you can understand that the electron motion of going in and out and the motion of the photon coming in is perpendicular to that. You're going to have the outcome of some kind of scatter. So depending on how fast the electron's moving, how much momentum it has, how hot it is, will decide how much deflection there is and where it is when you hit it. If it's really close to the proton, it's slowing down. If it's far away, then it's going to be going faster. So it's going to have more momentum depending on what its position is relative to the atom. So where it's in its oscillation is the quickest at the furthest distances from the at the midpoint between its furthest distance and its closest distance. That midpoint is its highest velocity. So it depends on where you hit the electron, whether it's moving fast in or moving very slow because it's almost to its stop position. And that'll decide how much of this bending vector you get. So that's why it's randomized, is because there's, you don't know at what position the photon coming in is going to hit the electron, whether it's its peak velocity or one of its slower velocity. And depending on that velocity, you'll decide how much deflection there is. So it's a really simple explanation that the photons that go near the surface are getting disturbed, okay? Their pieces are being fractured, okay, and bent because every time the electron moves into the field, just like me pushing my hand, it's pushing force bits. It's compressing them and recreating the photon. So the photon hits the electron, gives it momentum. That momentum is converted into motion into the field, and that motion into the field is going to create another photon, another element of a photon. And all you're really saying is that you're going to scatter a whole bunch of bits at this surface. And the simple truth is there's a 50-50 chance, okay, based on the length of these vector lines, that these bits are going to be in phase or out of phase. Those only are two choices, heading towards being in phase or heading towards being out of phase. And that's what the pattern duplicates, kind of obviously, is that the brights are bigger than the dark bands, and the logic is kind of obvious that it's, that you're almost making an in-phase photon, or you've gone to the point where it's almost completely out of phase. And it works as an explanation. The fringe pattern is being created by scatter at the surfaces. And what's also quite noticeable is that obviously most of the photons, it might be like 95%, it might even be higher, 97% of the photons go straight right in here, hit right here in the middle of the single slit. So that's another truth, is that 90% of the photons aren't fringe photons. So the fringe photons are a small percentage, especially the wider the slit is, the center gets insanely bright, and the fringes almost become washed out entirely because of the brightness of that center, indicating that now every photon doesn't get affected by the slits, and it's only the photons that travel near the surface that are affected. And obviously the more compact I make the surface, the smaller a volume of space, the more likely it is the photons are going to be bent. So that's why this gets very dim as you make the slit narrower and narrower, because now you're pretty much guaranteeing that all the photons will be fringe photons, because they're all going to hit the surface because you've made the gap so narrow. And so the wider the gap, the more light goes straight through. These are just, they're obviously deducible circumstances that can be understood, and it just abolishes their argument that there's no particle theory that can explain. Yes, there is. They just don't want to hear it, and they haven't given it any thought, and it makes perfectly good sense, frankly. And it's much better than their ambiguous, these fields are doing something, and then the photons are hitting each other and creating interference and all of this nonsense, when we can't shoot laser beam into laser beam and make photons bounce off of each other. Can't do it. Can't make a photon hit a photon, and yet they claim that these photons are interfering with each other in this space. So that brings up another argument against that theory, which is the radar experiment and the radio experiment, that clearly demonstrate that there's no there's no necessity for any interference to take place in space. So you can just set up a radio antenna and pump the same signal into both antennas, and then you can just move a receiving antenna through that field, and it will be in phase, out of phase, in phase, out of phase, the two signals, and you will get exactly the same kind of fringe pattern. You'll end up getting the signal. You can hear the signal because it's not creating a counter signal that's out of phase. So you can receive the signal, and you can't receive it because the two are conflicting with each other. Their timing is off. So you can't receive either one, and then you can receive both, and then you can receive neither, and then you can receive both. So the same exact pattern created, and the waves obviously are not interfering with each other in space. And it's clearly just about the phase of the events. They're either in phase or they're out of phase. They're either creating a mechanism that can reinforce a resident frequency, or they're not. And that's why different colors happen, is because different frequencies are the resident frequency, the frequency at which stuff vibrates. And if you add energy consistent with that vibration rate, then you can increase the rate of that vibration, simply put. You can add momentum to a system if you add it at a harmonic frequency, or the same frequency. That is an in-phase frequency. So if you create a frequency that's in phase with the event frequency that you're trying to get, so you could have this frequency that's in phase with this one, in the sense that the peaks are always at the right place. So you can add a smaller frequency and add energy to a higher frequency, or vice versa. Right, so we'll see what else we can add. Alright, so there are a ton of experiments that they've never done that they really should have done if they cared about knowing the truth. So in all this time that they've been doing these slit experiments, what they've never done is put photographic film here and here to see if the pattern actually does create photons at these high angles. Theoretically, if it was a wave theory, the strength of the waves, the signal received at all these locations, should be the same. So if they do it on a curved screen, a photographic paper, let's say, they should receive the same intensity at all locations if it was a wave theory, because that's what waves do. Okay, in water waves you get just as much intensity of water disturbance here as you get here. There's no difference because the disturbance is a prick in the water. It radiates outward and has the same strength of a wave front. So if a wave theory was consistent, they should have done these experiments a long time ago. And my argument would be is that if they have done them, they found that they don't collect any pattern at these high angles, because I would argue that it's an unlikelihood in traveling through the noise of a surface. The issue is that the photon could get jostled a little this way, and then it hits another electron jostled that way, and hits another one jostled. But it's very unlikely that it's going to be jostled enough to bend its path to something like this 90-degree angle. That would mean that the momentum of the electrons would have to be much higher than the momentum of the force bit hitting it. I would just argue that it's probably unlikely that the outcome is that dramatic, that it's more likely to be somewhere in this range than it's ever to be in these ranges. But the fact that they've never even tested, I mean, a foundational experiment, and they really haven't done any of this detailed analysis. So, not to even project it on a curved screen. They don't bother taking real readings, intensities over time. None of this has been analyzed by their physics. And again, the geometry, they had, again, their mathematics is completely dependent on the surfaces being essentially diagrammed as point sources. It's exactly how you would analyze it if you were to analyze it for scatter at the surfaces. Their math is exactly the way you would do that. So I don't know if I went into the big cheat enough, but I'll just go with that. So often when they do the double slit experiment, what they'll say is using infinitesimally small slits. And then they'll get a pattern. Okay, so this is what they'll do. They'll do a double slit experiment with these tiny slit differences here, tiny openings. And then what they'll get is a single slit pattern, because the fact is they've taken away two of the sources. And so they'll call this pattern, which is a single slit pattern, they'll call that a double slit pattern, when obviously it's not a double slit pattern. Sorry, that's not very well drawn. Well, I could redraw it, right? It only takes a moment. So yeah, more over here. All right, so that's the single slit pattern. We know the double slit pattern is this pattern. Okay, made up of small nodes, and that represent this other pattern, but aren't explicitly creating. So it's an envelope pattern is what they call that. That's the real double slit. And so when they make infinitesimally small slits, okay, what they're really just doing is ensuring that you only get a single slit pattern, because really you've taken 4 point sources, 4 surfaces, and you've changed 2 of them into the same, so you've just reduced it into a 2-source experiment. When you make the slits infinitesimally small, smaller than a wavelength, you're just creating 2 sources now, because these 2 points are right next to each other, same location essentially. So now it's just a 2-source experiment. Even though there's 4 surfaces, technically there's only 2 sources visually, as a practical fact. And that's why they get this pattern. And they call this the double slit pattern, when it's not. It's the single slit pattern. It's the pattern you'll always get with a single slit. And let's understand, you can also just do the single impediment experiment, and you'll get pretty much the same pattern. It'll just lack the intensity in the center, obviously. So if I put an impediment, and now again I still have 2 surfaces, and that's the key point, and I'll still get the same pattern. It'll just be duller. All right, it won't be as bright in the center, because obviously most of the light is getting blocked entirely, and so all I have is the fringe light here and the light that goes straight through on the outside. So it, it isn't as visually good a pattern because this is washed out a little bit because of the extra light going on the fringes. And but you're getting the same ideas. It's just scatter at these 2 points that are going to create all of the pattern. And so it's really the two source experiment, just like the two. So the single slit and the single impediment is really just the two source experiment. It's just the two surface experiment. That's the thing that makes them common. And that's why they look the same, is because essentially it's the same mechanical structure. Having the opening versus having the impediment is irrelevant. The surfaces are the only thing that's relevant. And that's the key point. It's all about the surfaces, and they're pretending it's about some opening that causes the photon to not know where it is, and it's all confused, and it thinks it's somebody else, and they all think they're one thing, and all this nonsense, when it doesn't physically happen. It's not physically correct. It's not accurate to describe it as anything other. Like, again, if you're going to argue it's waves, you have to explain how the wave, here's your surface, that the wave is created with its point in the middle of that surface, how it originates from this very edge, and how that magically creates a wave. And again, even if it did, the pattern doesn't represent wave behavior in the sense that its intensity fades with distance from the center, and it's not supposed to fade. Waves don't do that, as Richard Feynman would say. So anyway, so that probably is enough. I have other videos on the two slits where I probably mention some other little details, but it's easily dissected to be completely different than the propaganda they claim. It can be understood easily, mechanically. They don't explain the double maxima. They don't explain the true double slit pattern at all, the envelope pattern, and the small pattern inside of it. None of that is part of their explanation, and that is the that's the glaring reality of the experiment. That's the most outstanding feature, is the details of those two different patterns, the pattern of the single slit versus the pattern of the true double slit. Huge difference. Alright, so enough of a video. So till the next time and such. Probably 1/2 mv².